Let's consider the next question of this paper. If x equals 3 tan t and y equals 3 sec t, we have to find second derivative at t equals pi by 4. A simple question involving parametric form. Let's start it. We can write dy by dx is dy by dt upon dx by dt. Dy by dt, that is 3 sec t tan t, divided by next 3 tan t was there, its derivative is 3 sec square t. Simplify, this gives you 3 and sec t are cancelled, we are left with tan t by sec t or simply sin t. Differentiating again with respect to x, we get d2y upon dx square is equal to cos t multiplied with dt by dx. That is reciprocal of dx by dt. Dx by dt was 3 sec square t, so its reciprocal is required. So let's write down the reciprocal. This gives you cos t multiplied with 1 upon 3 sec square t. We have to find second derivative at t equals pi by 4. So d2y by dx square at t equals pi by 4 is equal to 1 by root 2 into 1 by 6 or 1 by 6 root 2. Let's look at the given options. Yes, it is available here as option number 1. So mark and mention as the correct answer. Moving on to the next one, that is question number 20. A, B, C, these are 3 vectors given, although B involves B1 and V2 unknowns. It is also given such that the projection vector of B on A is A itself. Projection of B on A is A itself. If A plus B is perpendicular to C, then we have to find B. So sufficient number of equations are available to solve it. Projection of B on A. When you talk about projection as the scalar quantity, you simply have A dot B divided by mod A. This is clear? Now, A dot B, when you talk about, it is simply B1 plus B2 plus 2. B1 plus B2 plus 2 divided by mod A, that is 1 plus 1 plus 2 square root, that is simply 2. This is the projection of B on A. Now, it is given projection vector is A itself. So when you talk about the projection vector, meaning when you take its modulus, B1 plus B2 plus 2 upon 2 is mod A. What is mod A? Let's see, because A vector is given to us, it is 1 plus 1 plus 2 square root, giving me simply 2. So this is equal to 2. This is clear? Simplifying, we get the equation B1 plus B2 is equal to 2. Mark it as equation number 1. Next, A plus B is perpendicular to C. Let's go with the approach. A plus B dot C is equal to 0. This is clear? Now, when you talk about A plus B, it is simply B1 plus 1, correct? Multiplied with C as the dot product, so we have 5. So 5 B1 plus 1, 5 into B1 plus 1. Moving ahead for next term, that is B2 plus 1 multiplied with 1 plus B2 plus 1. Moving ahead, the next term, that gives you root 2 into root 2 plus root 2, that is simply 4. So here 4. This is the condition based on the perpendicular. So this is equal to 0, giving me 5 B1 plus B2. Next 5 plus 1 plus 4, that is plus 10, is equal to 0. This is equation number 2. So we finally have 2 equations. One is B1 plus B2 is 2. Second is 5 B1 plus B2 plus 10 is equal to 0. Substitute B2 as 2 minus B1. When you put here 2 minus B1, what you get? You are simply getting 4 B1 plus 12 is 0, or B1 is minus 3. Then we get B2 as 5. B1 and B2 are obtained. Let's see what is being asked in the question. It says what is b vector? Its modulus. We have to find the modulus of b vector over here, and it can be obtained here as square root of b1 square plus b2 square plus 2. This is what we are looking for. Square root of b1 square plus b2 square plus 2, that is a square root of 9 plus 25 plus 2, that is giving me root 36 or simply 6. So correct answer of the question is option number 4. Let's move on to the next question of this paper, that is question number 21. The number of all possible positive integral values of alpha for which the roots of the quadratic equation are rational numbers. Roots of quadratic are rational numbers, meaning D is a perfect square. So let's start this question. Discriminant, that is 121 minus 24 alpha, is perfect square. Correct? Obviously it is greater than 0, greater than or equal to 0, you can say. Now we can check there exist only 3 values of alpha, 3, 4, 5, which will satisfy this constraint. So correct answer for this question is option number 4. Let's mark and mention this point. So this was about question number 21. Let's move on to the next, that is 22.